So when you're calculating these, you need to kind of consider either the ends, you will have a pair, or the voltages, you will have a pair. So in this example, we have our MP, which is 10, NS 1, VP is 20, and in this example, it's asking us to calculate VS. So the way I go about these is you need one primary and one secondary from either both the N or both the V. So in this example, we have MP and NS. So we will use those to create the ratio or calculate the ratio, which will then allow us to figure out what the ratio here is. So the ratio for the turns is a value on its own, but that ratio is the same as the ratio for the number of turns, and it's the same ratio for the voltage. So what I like to do is I do primary and secondary, almost like a little grid. Think of it like a grid. So we know our number of turns for the primary, which is 10. And we know our number of turns for our secondary, which is 1. So what we have to do is we have to calculate the ratio. Now, this example is a little bit strange because the number of turns is actually the ratio, but we'll go through it just to show that it actually is what it is. So what you want to do is you basically want to know how many times the small number fits into the larger number. So you would take the larger number, which in this case is 10, divide it by the smaller number. So we would do 10 divided by 1, which is 10. And that value is how many times the smaller number fits into the larger number. So that value is related to the larger number. And because it's how many times the small number fits into that, the small number becomes the 1. Doing it this way, you don't end up having decimal places and having to remember whether you're subtracting or adding or dividing. You're working with whole numbers this way. So we've calculated the ratio, which happens to be the same as the end value. This then allows us, so we have a ratio of 10 to 1. So for every 10 on this side, it equates to 1 unit on that side. So from the example, we know that VP is 20 for the primary side. So again, we can put in our V, which is 20. So we then need to calculate what the secondary value is. So if we look at this example, we know our ratio is 10 to 1. So anything on the primary side is 10 times larger than the secondary side. So because it's 10 times larger, to get that value, we have to divide whatever we have on that side by 10 to get our value. So in this instance, we would do the 20 divided by the 10. Which is 2. So our secondary would be 2 in this example. So the number of turns is 10 times bigger than the secondary. The ratio is 10 times bigger than the secondary, and the voltage is 10 times bigger than the secondary.